CoriMap offers a field-to-finish solution for 3D corridor mapping applications. We have all the tools for converting GPS field data into an accurate 3D base map, ready for sheet creation. An accurate 3D base map forms the foundation for all stationing. The process for creating the baseline involves 3 steps. The first is GPS transform, which converts GPS data into custom blocks and 3D polylines. Next, we profile the baseline. Then we use QC profile to correct elevation anomalies. The GPS transform process uses data exported from your GPS software. Originally designed for use with Trimble Pathfinder Office, the GPS transform process can use any DWG data which uses attributed blocks. The GPS block will be replaced with gospel blocks according to setup definitions you can save and recall. Gospel blocks are defined by you and can include all of the attributes you need. Ideally, you will design your GPS data dictionary and your gospel blocks together, so there's a gospel block for every feature you collect in the field. A GPS transform definition includes all the attributes you need and attribute passing definitions, from the GPS block to the gospel block in any way you need. This example shows attribute passing for the sign feature. Notice the date attribute in the GPS block is passed to 2 different attributes in the gospel block. Once your data dictionary, gospel blocks, and GPS transform definitions are complete, you can process a field file in under a minute. Let's take a look at the GPS transform process. Once you've loaded your saved setup, you will see all of the transform definitions. Each definition includes the GPS block layer, which mirrors the GPS feature. A setting for the new block name, which will be one of your gospel blocks, and layer settings for the block and line work. Scale and rotation settings complete the GPS transform setup. We start with a drawing that was exported by Trimble Pathfinder Office. This GPS block is named 30 and is on layer FO line CL. So we're ready to run the transformation. The results are exactly what we want. The new block is named FORL and is layered according to the transformation definition. After GPS transform, we have a 3D polyline that represents what we want to use as a baseline. Slope stationing requires an accurate 3D baseline, so the next step is to create a profile for the baseline in QC mode. A baseline will always be a 3D polyline. The Profile Baseline tool has many uses. Let's take a look. Profile modes include QC mode and several others, such as Draw and Frame mode, which is used to generate alignment sheets. The profiling parameters include settings for layer, scale, grid spacing, and the blocks to include. When you use a GPS-derived baseline, there's a good chance that elevation anomalies exist. QC Profile is used to allow you to inspect and correct all elevation anomalies. Here's our baseline profile. We'll inspect it with QC Profile. Here's an example of an elevation anomaly, what we call a buzzsaw, common to GPS line work. QC Profile allows you to specify 2 types of corrections, smooth and move. A smooth will adjust elevations in a straight line. You pick a start vertex and an end vertex. A move will add or subtract an amount to the elevations between the start and end vertices. Here we use the smooth option. We can preview it and add it to the fix list. Next we simulate all fixes in the fix list and then accept it. Next we run Fix Profile, which modifies the elevation of the baseline to give us an accurate 3D baseline. Now we can slope station the baseline and all blocks. With the Station Block tool, you can enable 2 special options. Snap Z to baseline changes the elevation of the blocks to match the baseline at the station point. Break baseline is an option that's often used with matchline blocks during sheet creation. Here's our sign block with the station and offset values set. When all of the blocks have been stationed, the next job is to arrange them in a readable format. The Arrange Attribute tool is the answer. Here we use the Auto Baseline Follow mode. At this point, we have an accurate 3D baseline and all map elements are slope stationed. We've got exactly what we need to begin the sheet creation process. CoriMap offers a field-to-finish solution for 3D corridor mapping applications.